is equal to I alpha. And now we start doing substitution. We have a formula for weight. So if F and I'm tired of subscript sometimes. We'll let FTA be big A. A minus MG, MAG equals MA little a. MBG minus big B equals MB little a. And down here, I got R FTA minus, FTP minus R FTA is equal to the moment of inertia. What's the moment of inertia of a disk rotating about its central point?
0.
No.
Okay.
There's certain ones that are just good to know. 1/2 mass of the pulley, radius of the pulley squared times alpha. Well, if I divide through by R, that R, and this R are all the same. In this case. I have done this problem where they were not the same. Just be aware of it. This R right here is the distance from the center to where the force is applied. This R right here is the radius of the pulley. They are the same in this case. So that means my second equation here now becomes B minus A is equal to 1/2 mass of the pulley, radius of the pulley, times alpha. Well, what's R alpha?
R alpha.
Yes.
R alpha is that our angular acceleration?
Alpha is angular acceleration. Torque?
No.
All right, let's look at the units. I got meters times alpha, which is a radian per second squared. If I multiply them together, what do I get?
Meters per second squared.
Which is a unit of,
Acceleration.
that's just A, little a. So my three equations are now A minus, and we'll just go ahead and put it on Earth 2. So A minus 40 is equal to 4 little a. 70 minus B is equal to 7A. And B minus A is equal to 1/2 times 3 little a. And I can just add them up. There are other ways of solving it, but if I just add them up, notice that the B's will cancel out, A's will cancel out. I'm left with 70 minus 40 is equal to 4 plus 7 plus 1.5A. 30 is equal to 12.5A, my acceleration, 30 over 12.5.
Four. 2.4.
2.4 even. Units?
Meters per second squared.
Previously, you did the Atwood's machine lab. In Atwood's machine lab, we assumed that we ignored the pulley. If we solve this in that case right there, if we assume still an ideal pulley or an ideal rope, The only thing that changes is this 1.5. We would have 30 over 11 instead of 30 over 12.5. This is what the pulley does. We have an additional mass that needs to be moved, that is moving, and it does cause, from an energy point of view, some of the energy goes into turning it, which means there's less energy to accelerate.
So if we had an ideal rope or an ideal pulley, we would just not have that 1.5.
Right. Yeah.
But we would still have everything else.
Yes. If, in that case, these two would be, A and B would be equal to each other, and they would cancel out with just that. At this point, you could do almost all of the Rube Goldberg test. And just as, I still view that as probably the most encompassing test in one problem. And 16 parts. Well, actually, count subparts. Probably 25 parts.
25 per 20 questions.
Yeah, so in essence, if the answer to your last question was right, then most likely everything else was right.
So it's called what?
Rube Goldberg test. Under old tests, be under like test 3, old test, something like that. I believe I have an arrow, if you scroll down, I'll have an arrow pointing to it, and it says, this is the Rube Goldberg test.
Have you taken it? Have you taken it?
Have I taken it? Yes, I've lived it too.
Will we take it in this class?
No, not necessarily. I mean,
150.
there's, I have a video of my going through the entire test before, as well as all the individual pieces, the answers are there. So, anyway, it was not a big hit among the students who took it.
I wonder why.
They got psyched out early on.
Wow. Was it like that daunting? Of a,
It was, because every part depended upon the previous part, so if you miss one part, the psychological, that's part I ignored, the psychological piece of it is, oh, I can't do the rest of it. But what I did, because to avoid that is, if you can't get this answer, use this number. And I gave the number in brackets, use this number for the rest of it. But that apparently still is not enough. Anyway, enough of past losses and victories. Let's talk about things being due. Let's see, we are here tomorrow and Thursday. We are not here the following week. There are classes Monday, I believe.
Yeah.
Okay.
For some reason.
Why don't we say Master Set? Well, 8's already been due. What are we chapter?
9.
9. So Master Set 9, due the 29th. And we'll have the homework quiz on 9 on the 30th.
are we here that week?
That week, yeah.
That's the week.
Oh,
We're gone next week.
Oh, you skipped the week. And,
Yeah.
and writing.
Yes.
You said the 30th was the test on 9 or quiz on 9?
Yes, the 30th is the homework quiz on 9. Please, for some of you, make sure you've worked through all the problems before you walk into the class. Actually, all of you should do that, but some of you especially need to look at the homework problems in advance.
You know, funny story. So when it came to the homework problems, I saw the part that said, here are the homework problems, or like, here's the homework problems you have to practice. So me and all my genius wisdom, I went to my textbook and started looking at the questions. Okay, there's not really solutions, so let me just start working through all of them. So,
Yeah,
and
again-
up to going, and then after chapter 8's then quiz, I was sitting with Jack and he was like, hey, you know he has the solutions right under it. I was like, so-
That and the problem that these don't mash up anymore. So
Yeah.
that probably won't change for this group, but hopefully it will change before I do one again.
What 52?
152 is probably out of sync also.
Yeah.
So let's see if we can get 152 in sync also. Anyway, with that, we sort of capped off rejoicing there. We come back on Thursday, we will be dealing with harmonic motion.
Chapter 10.
Or 16. We skip chapters and then we come back if we got time.
Okay.
Is the lab already listed for tomorrow?
I suspect not.
Okay.
Yeah, see if I can change that. If somebody could stop the recording also, that would be cool.